On today's episode of Where's Brian, we're headed to work with a department that's critical to your everyday life. They go to great lengths to move their product from deep underground to hundreds of feet in the air, and eventually right to your home. Do you know where I am today? I'm Brian Phillips. On most days, I work in an office for the Ames City Manager. Since starting here, I've learned a lot about the different jobs city employees have. Many of them you might see every day. Others work behind the scenes to provide quality programs and exceptional service to the community. And that's why I'm here, to experience the different jobs the City of Ames has to offer. You never know where I'll go next. The Ames Water Treatment Plant provides water to more than 14,000 homes and businesses. In addition to supporting the Ames community, it also provides water service to the National Centers for Animal Health and to the Iowa State University campus. The average home in Ames uses about 160 gallons of water each day. 1 penny will buy you about 6 gallons of Ames water, which means an average family's water bill is less than 50 cents a day. Today, we get to see what goes into getting the water from the plant safely to your home. Morning, Lyle.
Morning, Brian.
How you doing?
Doing good.
Well, let's start off by telling us a little bit about where we are today.
Yeah, we are at the State and Mortensen Water Tower. This is a relatively new tower. It was constructed in 2009. I was involved a lot in that construction, so I know all about it.
Okay.
And this is what's called a composite tank, which means it has a concrete cylinder or support structure and a metal bowl on top of that, which is where the water actually is. And this is a little bit different than our other water towers because of the way it's constructed. It was, like I said, constructed in 2009. It's the newest water tower we have, and it holds 1 million gallons of water.
So how does a water tower work?
Water tower has a few different main functions. One of the things is that it provides an emergency supply of water. Whenever we have a fire in town, we have the capability to fight those fires without having big reductions in water pressure, which otherwise would happen. If we didn't have these water towers, the water plant would have to run their pumps to try to match demand instantaneously or suffer wild swings in pressure, which isn't desirable. Also, there's kind of a misconception that water towers create pressure, which is actually partially true. The main source of pressure is the water plant pumps, but occasionally we turn the pumps off, and actually the weight of the water in the bowl pushing down creates the pressure when the pumps are off. So in a sense, it does at times help create pressure.
So it helps regulate the pressure coming to your home.
Yep, it helps dampen pressure fluctuations,
Okay.
so to speak, because again, there are times of large demand and sometimes the demand drops off. And with these, we're able to handle and maintain a pretty consistent pressure.
So how many water towers do we have in town?
We actually have 5 towers, 3 of which are in our distribution system. I'll start with this is SAM. It's a 1 million gallon tank. We I should take a step back and explain our acronyms. SAM stands for State and Mortensen.
Okay.
We like our acronyms. This is it, and they're all named according to the location.
Okay.
This is at State Avenue and Mortensen Road. We have what we call Brett up north. It stands for Bloomington Road Elevated Tank.
Okay.
And it's on, of course, Bloomington Road. That's a 2 million gallon tank. That's our largest tank. And that's the tower that just got repainted a couple years ago.
Okay.
It now has a blue pedestal and a white bowl. We have out west, we have what we call MAC. It stands for Mortensen and County Line Road, which again indicates its location. And that's a 1 million gallon tank. We have a tank that's actually currently out of service on North Dakota Avenue. That's a 1 million gallon tank. And we have a smaller tank that's dedicated to the National Animal Disease Center. It's not really part of our distribution system. It's kind of actually part of their facility, but we do pump water into that from a pump station.
Okay.
So in total, 5 towers.
All right. So tell us a little bit about what we're going to be doing today.
We are going to go up in the tower and take water quality tests.
Okay.
One of the things that we do as part of the water treatment process is we add chlorine for disinfection purposes. And of course, we monitor it very closely at the treatment plant itself, but we also monitor the chlorine level, or the residual as we call it, out in the distribution system. Water towers, especially this time of year when it's been so hot, this last month or two, water towers can stratify if you don't operate them properly. And over time, if you don't move enough water, so to speak, it can stratify, and the warmer air or the warmer water stay on top and just kind of go up and down like that.
Okay.
So what we're going to do is take chlorine samples at different depths and to see if the chlorine residual profile is relatively consistent.
Okay, and to do that, we've got to go where?
We've got to go up to the top,
Okay.
which every tower is a little bit different, and this one has actually a continuous ladder all the way up to the
Okay.
platform, which is right below the bowl, and then you go up through an access tube through the bowl. So it's quite a climb. It's about 150 feet to the top.
Okay.
Of course, climbing towers, we don't do it very often, but safety is paramount.
Okay.
So the first thing we're going to do is harness up,
Okay.
and we do get actually regular safety training once a year about climbing towers. Like I said, we don't do it very often, but safety is paramount, so we want to make sure we're taken care of in that regards.
Okay, well, I'm ready to get harnessed up if you want to lead the way.
Okay, let's go.
Okay.
What we're going to do is open up this hatch, which that hatch lets us come up onto the top of the tower. This hatch lets us actually look down into the water.
So we just came through a tube inside the tank.
Yep,
So there was water all around us, and
Yeah,
now we're going to open the hatch and look into the water.
that's right. You probably noticed it got a little cool once
Yeah.
you went through there and
Yeah, it was
warmed up
nice.
again. That's exactly where the water was.
Okay.
So this water here is about up to 38 feet deep, I believe, is where the overflow is. So
Okay.
we're going to open this hatch, which looks down into the water, and then we're going to do a couple things. We're going to, a week ago, we put in some temperature probes.
Okay.
They're actually measuring the water temperature at the different elevations, because remember I said warm water can stratify the
Okay.
tank.
Yeah.
And we're just going to make sure that's not happening to see if it's relatively uniform.
Okay.
And the other thing we're going to do is take chlorine samples. And again, I mentioned the chlorine residual. We test those at different depths, again, just to make sure it's uniform. And so enough mixing is happening to make sure the water quality is what we need it to be.
Okay. Well, show me what I need to do.
Okay, let's go ahead and open it up. What we're looking at here, there's a ladder right here that if you wanted to actually get down into the bowl, you could.
We're not doing that today.
We're not doing that
right?
today, that's for another day. But what we're going to do is pull out this cord which has the temperature probes on it first. Again, that's
Okay.
been in for a while, so go ahead and take that out, and we'll just lay the probes out over on that side of the hatch.
Over on this side?
Yep,
Okay.
I'll help you do that. Just kind of,
So this is what one of the probes looks like?
yep, that's one of the temperature probes right there.
Okay.
A little bit slower so I can loop this up.
Sure. So you said this is, these probes have only been in for a couple of days?
Yeah, they're
So this isn't something you do regularly?
No, this
Okay.
is, in fact, we've never done it on this tower. We've done this with our Bloomington Road tank, but never this tower yet.
So this is kind of a specialty test?
Yeah, these are what's called data logging probes, so they actually continuously monitor the temperature real time. And we download the information onto a computer.
Well, if that metal pipe is any indication of the temperature, it's pretty cold in there.
Yeah, it is.
How cold is the water usually when it's coming into the water tower or coming into the home?
Coming into the plant, it's about 55 degrees Fahrenheit, and really leaving the plant, it's not much warmer on a day like this, or even colder much in the winter. So it usually comes out around 55 degrees also.
So it stays pretty consistent year round then?
Typically.
Okay. All right, so what's next?
Okay, next thing we're going to do is we're going to pull this contraption out that actually allows us to take the chlorine samples.
Okay.
So let me get right back here where I was. Show you how this little thing works here.
Sure, this looks pretty unique.
Yeah, it is kind of interesting. What we do is there are markers on this rope which tell us depths. There's markers every 10 feet, so we'll know exactly how deep we drop this thing.
Okay.
And we attach this little cable to here. We do that on both sides.
Okay.
And then we'll lower it down in the water. And I'm going to have you drop this copper thing, and it falls down on this and allows this to snap shut, and it holds the water in there.
So that'll secure a sample at just that depth.
At just that depth that we want. And then we'll pull that back out. And we've got some plastic bottles in here that I'll have you get the sample from.
Okay. How many
we'll
of
do it
these?
again.
How many of these are we going to be doing?
We'll do 3 or 4 of them.
Okay.
Depends again on how high the water level is in this tower right now. How
Okay.
many we can do. You want to hold that for me, just the copper
Okay.
thing, and I'll go ahead and lower it in. The first one just a couple feet below the water.
Okay.
And here you can see the water below. It's about 10, 12 feet below us right now, the top of the water level.
Okay.
So we'll go ahead and lower that thing in. See, there's the first 10-foot marker.
Okay. So the water's just a little bit beyond that.
Yep. Kind of hard to tell. So it looks like it's maybe closer
maybe
to
15.
closer to 20 feet down. See, again, it's kind of hard to tell exactly
it's distance.
looking here
Looking
where you're
down is
at.
tough.
So there, it just touched the top of the water.
Okay.
So here's I believe the 20-foot mark. So that's roughly a foot. So we'll go ahead and drop it a couple feet down into the water, and then take our first sample.
Okay.
And I'll let you have the honors of dropping the copper thing. I'll go ahead and hold the rope.
Okay.
And when you drop it, it's going to hit the surface. You'll hear that, and then you're going to hear a whoosh, like that when it actually opens up and takes that sample.
Okay.
Okay?
That came pretty quick. Huh?
Yep, because it's not very
It's
far
not very
down.
deep down there. Okay.
So go ahead and
Now we
pull
hoist
it
it back
up.
up.
Yep. Okay.
All right. So I take it this is going to be kind of wet.
Yeah, we'll hold. You hold this the first time.
Just hold it over the tank or hold
Yep,
it?
hold it over the tank.
Okay.
And then simply pull this out, and you hold the bottle underneath and get the water as it comes out.
All right.
Get a bottle full?
Yep. That's pretty good.
Okay. Empty this side of it.
So when we have the tank open like this, are we worried at all about things getting in and contaminating the water?
If we would leave this open, yeah, there's a chance to get birds and things like that in. There is a vent right here that's technically open all the time, but there's a screen to keep stuff out of it.
Okay.
So
with this much water, you know, us spilling a little bit on the device or on our hands isn't going to make much of a difference.
nope, because again, there's that chlorine residual that continuously disinfects things. So then we'll just go ahead and write the depth. We'll write 2 feet below water surface right there.
Okay.
And then we'll put it down another 10 feet and get a second sample.
So how often do we do tests like this?
This is 20 feet. Well, like I said, for this particular tank, we've actually never done this type of sampling. Now we take regular distribution system samples. One of the locations is here, but we just take it down at the bottom of the tank. But as far as a profile sampling like this, we've never done it here. We have done it at the Bloomington tank.
Okay. All right, so where are we going to now? We've hit 20 feet.
Okay, so how?
That mark.
Okay, so there's the water level right there.
Yep.
So let's go 10 feet further than we did last time. So
Okay.
we'll go to just to about the next green mark.
Okay. Just coming up right
Yep.
here.
We'll go
So
ahead.
right about there?
Yep.
Okay.
So
You got the weight?
I've got the weight this time. Okay, I think we're good to go. You hear that?
Yep, I heard it.
It took a little bit longer, of course,
Yep.
because it's deeper. So go ahead and
To
pull
yank
back
it
up.
So one thing that surprised me when we were coming up here is that there's really not a lot underneath us.
Mhm.
The pedestal of the water tower is just completely empty almost.
Yeah, the pedestal is simply for structural purposes
Mhm.
to get the water up into the bowl. You know, we call them water towers. Actually, a more accurate description would be elevated tanks. Some people do call them elevated tanks because that's what it truly is. A 40-foot high bowl of water elevated on top of that pedestal. So, no, a lot of people do think the entire column down is full of water. In our water towers, that is not the case.
Okay. Just emptying this out.
Yep.
So what happens if we were to drop something in the tank?
Well, if we drop something in the tank, we probably wouldn't get it for a few years.
Okay.
We do actually get in these tanks periodically to do maintenance and inspection. This tank was constructed in 2009, so we did a 2-year inspection just last year. About this time, we went in, well, we drained the tank, went in the bowl, inside the bowl, and made sure the paint job was still what it needed to be. There was some touch-ups that needed to take place, so we did that. And just structurally make sure everything is what it's supposed to be. And they put together a report and they document it. And then we do them on 3 towers, 1 a year. So
Okay.
another couple years, 2-3 years, this one will be done also. Again,
Okay. So if we were to drop something in, that's when we'd be getting it back?
that's when we'd be getting it back. That's right.
Okay.
So
All right.
anyway,
So now that we've got a couple of samples,
that's all there is to it, really.
What are we going to be doing with those?
We're going to be taking these samples into our laboratory, our water plant laboratory, and one of our operators, Mike Buns, is going to help us out do the chlorine analysis with what's called a spectrophotometer.
Okay.
So it doesn't take very long, but we'll give some more explanation when we get back in the lab there.
Well, I'm looking forward to seeing that. Let's, I guess we'll clean up here and head back down to solid ground.
That's right.
Okay.
Okay, sounds good.
All right.
Hey, you must be Brian.
Hi, Mike. How are you?
Doing great.
Well, I got some samples here from the water tower.
Okay, so you came in with Lyle, huh?
Mhm.
Well, I got you set up here. Kind of got your beakers and stuff ready to go. Have at it. You kind of know what to do, or?
Maybe you could explain to us the process before I get started here.
All right, you're going to be testing for total chlorine.
Okay.
We want to make sure that in the tower, the chlorine residual is consistent.
Okay.
If it varies quite a bit, then we got some problems with the tank. We need to lower it and mix it a little bit better. So what I need you to do, we've got a spectrophotometer.
Okay.
That's going to measure the color intensity. The more color, the more chlorine you have.
All right.
You've been to the swimming pool where they got that little color wheel. The lifeguard is always checking the chlorine residual. You're kind of doing the same thing, but this is like a $3,000 color wheel that those guys use. So
All right.
it's really sensitive. Also, we need some safety glasses. Got
Okay.
to have your safety glasses working in the lab here. Just
Okay.
proper protocol. Run one of these before? Grad cylinder,
No,
25
can
mils.
you walk me through it?
Okay, got a grad cylinder here, 25 mils. Now when you fill it with your sample and DI water, you have a meniscus.
Okay.
It's kind of like a concave
Like a little bubble.
little bubble there, and you
Okay.
want to line it up at the bottom of that.
All
You
right.
pour it into your beaker, and you got a 50-50 sample going on.
Okay.
So have at it. There's your water. Here's your beaker or your
Okay.
grad cylinder.
So we've got our first sample here. Should I
All
start
right.
with that?
I'd start with that.
Okay.
All right. Now, when you pour this on out, make sure you got clean utensils. I got clean glass. I cleaned these all out before you got here. Now, with your grad cylinder, you're using the same grad cylinder. So rinse it on out first with a sample.
Okay.
There you go. That's good. Kind of shake it up a little bit. Because if there's anything in there that could give you contamination and a bad result, we want to make sure and just
And dump it in here?
dump it in there.
Okay.
All right. Now measure out a good 25 ml sample. You want to try and get that meniscus right up there, pretty close. There you go. Looking good.
Pretty good. Okay, and that goes in the beaker.
Correct. And that's number 1. As you notice, you got them all labeled here, 1 through 5, all lined up here. This is good.
Okay, so start with number 2 then.
Start to number 2,
Okay.
and you rinse it out again, just like you did the first time. All right. So you got a total of 5 samples up there.
A little bit more.
We get it down to a flick after
Yep.
so many years. Get pretty good at it. You're doing great. So
Okay.
I'll go ahead and mark this suckers on down here. You got 1, 2, 3. So these are different depths in the tank. Is that right?
Yeah, we took measurements every 10 feet.
10 feet. So that's first is 10. That's 20. Alrighty, and hopefully our residual is going to be pretty close to each other, which means we're pretty consistent in our tank. We don't have stratification in it, and all our water is pretty fresh stuff.
So the danger in stratification is just that it's not consistent.
It's not consistent. It might be old water.
Okay.
I mean, these reservoirs, these elevated tanks, very good, are up there. They stabilize our pressure. They make sure that if we have a main break, that this water here will kind of keep a pressure on our main so that nothing from the outside can get inside the broken main, contaminate it. It's always flushing on out. So they have a lot of purpose. But being that we have this storage, elevated storage, that water takes a longer time to get to your tap. And we just want to make sure we can change it out. Kind of like a grocery store and produce, they want to keep the fresh
Sure.
stuff going. So this
So
is,
you've always got to keep the water moving to keep it the freshest
that's right.
and the safest.
And we got to run tests to make sure it's data-driven decisions. We're going to make sure we think it's going out there, but we just want to prove that it is.
Okay, so I've got
Got all the
25
samples.
milliliters of sample water in each one.
Correct.
Now we go to the deionized
DI water, because we want to dilute it down to a 50-50 mixture.
Okay, so I've got to
Rinse that out.
This one.
Because you don't know what's in it, go ahead and rinse it out, right?
Oops.
It's water. You're not going to
Okay.
disappear on it. There you go.
Okay.
Now measure out
And
25 mils in each of those.
milliliters.
You got it.
Okay.
Must have been pretty warm on top of that tank.
Yeah.
Yeah, on top of that tank, you guys are pretty high too. Must have had a pretty good view of the city.
Yeah, it was a great view. I'm glad to be back on the ground though. Okay, then what's next?
So next part, we got to set up our spectrophotometer.
Okay.
All right, and you hit your first button there, and then it'll pull us into, and we're going lab tap, hit enter. Right there, you got it. Now what we're going to do is take our sample, and for instance, this is our sample here, we're going to pour it into our pour through.
Okay.
This is going to flow on through, in through a sample cell and back out again. So we
the
don't
water's
have to
flowing
do,
through the machine, and then
Correct.
it's going out, back out to the sink.
To the
and
sink.
Going down the drain.
that's correct.
Okay.
And then you hit, we're going to zero it because there's nothing in there.
Okay. Just
clean.
deionized water.
There shouldn't be any chlorine in deionized water. And
Okay.
right now you can see it's 0 milligrams per liter.
Okay.
So we're good. Now we got a timer thing here. Once we get the first one going, we're going to hit that timer.
Okay.
Now, each one of these is from Hawk. It's total deep ED test. It's a powder pillow. You shake it on down, you cut it off. That's one pillow for every 25 mils
So we need 2 for each one.
for each of those. So go ahead and begin.
Okay. So this is like an indicator.
Indicator. It'll react with chlorine. And the more chlorine you have, the darker red it will be. And again, we're shooting for about 2.5 or 2.4 to about 2.8, 2.9.
So the machine is really taking a look at the color of the sample based on what the indicator
Correct.
has created.
Again, this is total chlorine. All right, now you got that in there. I'll get all the ingredients, swirl it around a little bit, and hit the timer. All right,
Okay.
you got 3 minutes now.
So that's got to work for 3 minutes?
Correct. A minimum of 3 minutes.
Okay.
All right, you can start pouring the first one.
Okay, so just pour in enough
Pour
to
in there,
make it
just-
about to there?
Correct. Only about 10 mils is actually being used in the cylinder itself. As that flows on through, it flushes it out about 3 or 4 times until you
Okay.
get an actual color. You can see the different redness that we have going in here. So we do have chlorine, which is great. But how much? That's what the machine does for us. It tells us. Okay, since it's done flowing, hit your read button,
Okay.
and what do we got?
2.51.
Good number. I
Okay,
like
so that's
2.5.
within our range.
That's
right?
within our range, and that's our timer going off, which is okay. Now we need to rinse in between
Okay.
each of the samples. We've got to flush out the reagents. So
To
you
make
take
sure
it-
that this sample isn't being
correct.
contaminated by
Nothing
this
gets
one.
carried on over.
So some more of the water.
You bet.
So remind me again, what's the normal range?
We're anywhere from I'd say 2.4 to about 2.8, 2.9, somewhere is on the top end. I don't think we're going to see it that way because the water's already been out there for a couple of days, and so the residual usually drops off with time.
So how frequently do we do tests like this?
We go out twice a week.
Okay.
Again, this is a process lab. Now, on the north side of the building, we have a regulatory lab, and they're a little more sophisticated and a little more detailed as far as what kind of numbers they generate. They want quality numbers. In a process lab, we want to know what the numbers are today. We can't run tests tomorrow to see what we're doing today. So we have to run them today, right now, so I know where to adjust my chemical feed. So this is process. All right. She's kind of flowing through there a little bit. Raise it up. Let gravity do the thing. Hit your read button. See what you got. It should be back down to 0 or pretty close.
0.05.
All right. So we
need
need
a
to
little
rinse
bit
it out a
more.
little bit more there. There we go. Oh, I gotta let you go.
Oh, that's okay.
all right. Make sure we get enough DI water. They do about 60 samples a month over there, and they do chlorine residuals, phosphate, fluoride. They do the same test I do, so we see if the water changes any.
Okay. So the testing you're doing here is to make sure that the water coming out of the plant is a consistent,
quality.
safe product?
Correct.
Okay.
And then regulatory tests it out there to make sure it hasn't changed any.
Okay.
And so we kind of compare results and see if we're doing. Now hit your read button, see what you got. Hopefully it's back down to 0. Good enough.
Yep, so
All
it's
right.
cleaned out. So we're on number
Second,
2.
You bet. All right, so that's sample number 2. Must have been about 20 foot down. Ah, it's flowing better.
There we go.
So the water towers are an important aspect to our distribution system. Not only do they store water, but they give us pressure. That's why you always see water towers higher than a lot of the houses and stuff.
Now, when we were up on top of the water tower, we also pulled out some temperature probes, I think. What do you do with that information?
Again, that'll back up the same thing as our chlorine residuals. The longer that water sets in there in the summertime, the warmer it's going to get. And so you'll see the temperatures higher up here as the temperature of the water, I think, is, I think we had it 14.5 degrees centigrade. And up here you might be around room temperature 75 to 100 degrees centigrade.
Okay.
So once you pull those probes on out, she'll put it in a spreadsheet and she'll create a chart and we'll look at it. And we'll save that as a baseline or a comparison to previous data.
Okay.
It's good to know. Data-driven decisions.
So this is all that we're going to do for the testing today then?
Yep, and I got to clean all this up as you go on to your next project.
Okay.
So, That's
well,
my job.
this has been really informative. Thanks for taking the time to
Hey,
show
you're
us.
welcome. Anytime.
All right.
Anytime. Appreciate
Have a
it.
good day.
Thank you.
Well, today we got to see the great lengths and heights the Ames Water Department goes to provide quality water to your home. Be sure to tune in for the next Where's Brian, because you'll never know where I'll go next.
By the way, if you talk in a normal voice like this right now, you can hear it perfectly down there. So, is Alex there?
Alex is the best camera operator in the world. Alex is awesome.
Well, getting to the top of the State Mortensen Water Tower is a lot more difficult than it looks. Well, this is only somewhat terrifying.